Okay, so we talked about twins, which is a great way to look at, okay, you share genes. What if we raised you in separate environments? Adopted children give us the opposite opportunity to examine the role of heritability. We take people who don't share genes and raise them in the same environment. So we have adopted children who are being raised by the same parents, but not the parents who gave them their genes. It's really hard to parse out the role of parenting from the role of genes when the child is being raised by the parent who gave them their genes. It's really hard to pull those apart. So adopted children are a great opportunity to try and explore that question. So on the left, we have the biological parents, and they donated their genes to the child who then got adopted and reared by the adoptive parents. That environment, that household environment, is what in psychology we call the shared environment. This would be the environment that if this adopted child has any siblings being raised with them, whether they're sharing their genes or not, but they're being raised in that same environment, in the family, we call that the shared environment. The unshared environment would be things that happen to the child outside the household that aren't under the control of their parents and probably didn't get experienced by their other siblings. So we call that unshared. So we're looking at shared genes coming from the biological parents and shared environment being provided by the adoptive parents. All right, so here's a chart that reveals the results of a study where they looked at children who were adopted or not at the ages of 3 years and 16 years. On the y-axis is the correlation between the child and whichever of their parents we're making the comparison with on verbal ability scores, which is one measure of intelligence. All right, so just to try and make it a little simpler, I tried to color code things. So we've got the adopted child being correlated with their adoptive parents in the blue bars. And we've got the adopted child being correlated with their biological parents in the red bars. Okay, so, whoops, I thought I had one time where they both were overlapping. Okay. So if we look at the correlation between the child and their adoptive parents, at 3 years, you see a pretty decent correlation, even compared to the biological parents. So at 3 years, it's looking fine. By 16 years, that's gone down. They become less like their adoptive parents as they age. And one of the things that we know is that as we age, our biology starts to take over with regard to cognitive abilities. And so by 16 years of age, there's really no correlation at all between an adopted child's intelligence and their adoptive parents' intelligence. So environment doesn't seem to play much of a role in that developing child's intellectual capability. Now, if we look at the red bars, which is where we're comparing the adopted child with their birth parents, we see that at 3 years of age, they're not really that much more correlated than the child had been with their adoptive parent. But by 16 years of age, all of a sudden we're seeing really strong correlation between the adopted child and their biological parents. Now, that last green bar is looking at children who are raised by their biological parents. And what you see is that, at 3 years, the intelligence score is the highest in the children. The correlation between the children and the parents who gave birth to them and are currently raising them, that's the highest bar, that green bar. By 16 years of age, there's not much difference between the children the correlation between the children and the parents who raised them and gave birth to them, right, that green bar, and then the adopted children and their biological parents. There's not much difference in the height of those two bars, which shows you that biology is probably the most powerful explanation for intelligence, at least with regard to, comparing them to their parents. And biology is supported, an interpretation that biology influences intelligence is really strongly supported by adoption studies. This is oftentimes really surprising for adoptive parents to hear this, and they think that, they kind of don't like it because they think that their environmental influences are having more of an impact, and they probably are on a lot of things having to do with the child. And how the child's going to turn out, and how the likes and dislikes and the style of life that the child adopts. What we're talking about right here is a trait that is largely biological, and those other factors are not. So on very narrow things that we think are biologically based, we do see evidence for that in adopted children. Mom says, "Why are you so obnoxious?" Child says, "Heredity." Right? A lot of times parents are fine that their kids kind of look like them, unless the kid has inherited a trait that, physical trait that the parent doesn't like. Oh gosh, I hope my kids don't get my nose, right? Oh gosh, I hope my kids don't get my freckles, whatever. Parents oftentimes are hoping that their children won't have their least desirable trait physically. But a lot of times with appearance, we're a little less, dismayed than when we see them acting like us. A lot of our behaviors are things that mimic what our parents do. And there's been a long debate in psychology about, well, are the kids picking up those behaviors through observation and it's really just about learning? Or are these things more hardwired and they would have emitted those behaviors even if they were never around that parent? And that's where, adoption studies and, twins who were adopted out at birth, these are really good sources of evidence for the heredity argument, that these are traits that are heritable. One of the traits that we think might be heritable is emotional style. Here's a nice little graphic that shows you, you've got neutral in the middle, and then you've got, these aversive things, anxiety, confusion, apprehension, all on the aversive side, like the negative moods or emotions. And on the right, they call it appetitive. These are the more pleasant, kinds of experiences that you might have, or emotions you might experience, like comfort and hopeful and fascination and all these kinds of things. When we talk about affective intensity, we're talking about how intense the emotions are. Affect is another word for emotion. So affective intensity is, the strength of the reaction that the person, or in this case, cat, has to stimuli. I think we can all agree that cats have a lot of emotional intensity when they have reactions, right? So the strength of the reaction, the intensity of the response to positive stimuli. So here we have a child who's just so happy to see whatever she's seeing that she's just like can't control herself. She's rubbing her little hands. You could imagine that she's sort of doing a little, probably her little feet are stamping alternatingly, like she's super having a very intense response to positive stimuli, right? And then the intensity of response to negative stimuli. This is a picture of a baby who had been sucking on a sucker, and then they took the sucker away and took their picture. So we have a very intense negative reaction. So you may have very intense positive reactions and less intense negative reactions, or vice versa. People vary on these things. What they find is that there's no real link between affective intensity and then emotional stability. So knowing that you experience these things intensely, let's say a big strength and you're intense on positive and you're intense on negative stimuli, doesn't tell us anything about how changeable your moods really are, or how changeable your emotions really are. Those are independent of each other. So how can we measure affective intensity? One way is to do a time sampling procedure. So in an adult, you typically wouldn't use these measures on children too often, but on an adult, you have a participant who reflects on the day's emotions and averages them out to determine whether overall they had positive or negative emotions. One of the drawbacks is that this can be time consuming. I mean, you're going to be asking them to do this for like every day for a month. You might even go longer if you have a good grant. So it is time consuming. And then I think even more importantly, people, when looking back on what happened today, have a response bias towards remembering more positive or more negative emotions. Like each of us kind of vary on which one's going to stick out more. Some of us who are a little bit more pessimistic might remember more negative emotions. Some of us who are a little bit more optimistic might remember more positive things. And if that individual has a response bias and they tend to remember one type of emotion more than the other, they're going to be more likely to have these the whole day recalled as being more positive than it really was, or more negative than it really was. It's always risky whenever you ask participants to remember anything, even if it's only a few hours old. You're asking them really to do something kind of hard. So often things happen and move on and we don't even really encode it, let alone, think about it or process it. So another way to measure affective intensity is to use something called the affective intensity measure, or AIM. In this measure, we have word. It's more of a survey, and so we have a survey that has been really carefully worded to get rid of response bias by phrasing some of the questions in a positive way and some of the questions in a negative way. It asks questions that will draw their attention to physiological aspects of emotions, cognitive aspects of the emotions that a lot of times in time sampling, people don't spontaneously necessarily think about all of those things. So by administering a survey, this, affective intensity measure, you can lead the participant to think about their emotions differently than they might have just automatically done. Of course, huge problem with this technique is that you're asking people to talk about how they typically are rather than really tapping into the fluctuations in a given day, or getting a kind of real-time reactions. So it's got a problem because it's sort of asking again the person to sort of reflect on their life and how they typically respond rather than like what's going on right now. All right, so that brings us to the topic that I keep mentioning and we haven't really delved into yet, which is emotional stability. Hans Eysenck was the first person to really talk about emotional stability, and he coined the term neuroticism to describe it. He later changed the name to emotional stability because it was a little close to, the psychoanalytic theorists who call people neurotics. So he was like, yeah, it kind of could be mistaken. So he started calling it emotional stability. Later, when we get to the trait theory, I'll give you a mnemonic device to help you remember the big 5 traits, and you'll notice that it relies on the word neuroticism to make the mnemonic device work. So it's something that's still in play, but most of us now like to use the word emotional stability. I'm not sure that's a huge improvement because a lot of times when people hear emotional stability, they think it's a euphemism for like whether you might have major depression or you might have anxiety disorder, and they're thinking a lot more sort of psychopathologically, like there's really something wrong rather than it just being a personality trait. The really interesting thing that Eysenck offered was this idea that he offered that not everybody buys, but man, there's some evidence for it, that if you have a more reactive limbic system, you're going to have more emotional instability. And he really thought that it was genetic, but that certain things could cause you to acquire a more reactive limbic system. So I think it's important for us to remember what the limbic system is. Sorry if you're scared of snakes, but that's what I've got a picture of. The limbic system is the middle range area of your brain. So you've got, like the lowest part that's called the brain stem, and it handles very low level breathing and eye blinking and, being able to balance and just like really low level things. You go up another level and you're in the limbic system, and now you've got structures like the amygdala, which is what Eysenck was most interested in. You have an amygdala on either side of your brain, and this structure is known to be associated with, if you stimulate one area of it, it makes you very angry and aggressive. If you stimulate another area of it, it makes you very fearful. And so he thought that if you had a lot of activity in the one area, it would make you more fearful, more likely to, have negative reactions like that. Or the other area, it would make you more like short-tempered, things like that. So emotional instability, basically. So he thought it was probably genetic, that most of us probably inherited the way that our unique limbic systems are organized. But he also acknowledged that it could be acquired. And one of the things that modern researchers have been looking at is the possibility that, a single powerfully traumatic event could alter the way that the amygdala reacts to stimuli going forward. And so he may have been kind of more right than he thought he was. I mean, I don't know if he knew to what degree he was actually describing things that we would find out later. So he also talked a little bit about factors that might happen in childhood, right? That experiencing childhood stress, being under what some of you may know the term ACEs, which is adverse childhood experiences. There's another one, early childhood. Can't remember what the other letter stands for, so I'm just going to stop with ACEs. That experiencing a lot of stress in childhood, and a lot of people don't know what stress in childhood really means. It would be things like, really intense parental fights, in the household. It could be, the death of a family member. It could be being in a car accident. It could be being victimized sexually or physically. Any like really intense childhood stressors. That can cause the child to develop a chronic fight or flight response, and they will experience higher levels of cortisol. And norepinephrine is that neurotransmitter that gets you ready for fight or flight. It also can cause hyperresponsive stress responses where you can't really figure out a way to calm yourself down or a way to cope with the situation because it's chronically going on, and your previous attempts to calm down were just met by further stress, soon thereafter anyway. All of this can change how the brain is structured. In a child, especially whose brain is getting wired up, it can be impacted by that. And so he acknowledged that, yeah, some of us are probably born already more reactive, and others of us may have acquired it in either childhood or even us adults having like a really powerfully traumatic experience that can be enough to change our brains forever. So, normally, if you were face to face in class with me, I would assign you, I would pass out little lemon wedges and ask people to taste them. And we can't do that. But if you want to, you can taste, lemon juice or something that's really super sour or super bitter. And if you have a really big physiological response to it, your whole body shivers and you're like, blah, you can't help but utter words. It could be that you've got a more reactive limbic system, as opposed to those of you who can sort of be like, wow, that was tart. And none of the physiological responses. It might be that you have a less reactive limbic system. So that's one way that he thought we could kind of test that. All right, let's go ahead and stop here, and we will return to talk about how emotional stability might affect social behavior.